Welcome to the Mood Ring Part 2, Coding Your Ring. In this video, we're going to do Activity 10. Activity 10 is going to cover a number of interesting concepts such as thermal energy, heat flow, temperature, and thermometry. To do this activity, you're going to need something cold. I've got some frozen chicken out of the freezer. Well, you may not want to use frozen chicken. It may foul up your dinner. But get something cold and pause the video now, get everything together, and then resume the video and we'll get started. Let's take a closer look at thermal energy. The thermal energy that an object possesses is due to all of the motion of the particles that make up that object. An object like the temperature sensor is made up of a bunch of particles called molecules that are moving and vibrating inside of the object itself. The faster that these particles move, the higher the temperature. Cold objects have slower moving particles, and a thermometer would measure the temperature as a lower value. So temperature is really just a measurement of the movement and motion of all of those particles. Hot objects, the particles move fast. Cold objects, the particles move slow. A thermometer measures the motion of those particles, and that's what temperature is. Heat is the flow of thermal energy from one object to another. Heat is different than temperature. When heat leaves a hot object, the motion of those particles slows down and it becomes cooler. When heat enters a cold object, the motion of those particles becomes faster and it warms up. There is actually a law in science that says that heat always flows in the same direction. Heat always flows from a hot object to a cold object, not the reverse. So when you open up the refrigerator and look in there for something nice to eat or drink, and you feel the cool on your face, remember, the refrigerator is not giving off cool. Instead, the heat is flowing from your face into the refrigerator. So think of the refrigerator as a kind of vacuum cleaner that's sucking the thermal energy out of your face and putting it into the refrigerator. In fact, if you put your hand in the back of the refrigerator, you can actually feel the heat coming out of the refrigerator once you close the door. That's what refrigerators do. They pump heat from one place to another. So temperature is a measurement of thermal energy, while heat is the flow of that thermal energy. Let's think about this in terms of our thermometer and a tray of ice. Our temperature sensor is warm relative to the ice, and so heat flows from the temperature sensor into the ice. When the heat flows out of the temperature sensor measures a lower temperature. Similarly, when the temperature sensor is placed on the fingertip is relatively warmer than the temperature sensor. And so heat flows from the finger into the temperature sensor, making the temperature sensor hotter, and its measurement goes up. So now that we've learned a little bit about temperature, thermal energy, heat flow, and thermometry, let's go ahead and explore the world around us using the temperature sensor. In activity 10, it suggests that we use the previous program that we wrote to measure temperature and explore various things. So for example, what is the temperature of your room? How about the temperature of your skin? How low of a reading can you measure? What's the temperature of an ice cube? So we're going to try all of these things, of course, unless you're chicken. So I'm going to go back to the previous example program, and here is my program, and I'm going to see how cold my frozen chicken is. So I'm going to press Control R, and oh my golly, it's 4 degrees centigrade. That's pretty dang cold. That kind of ruffles my feathers to think about how that cold that is. All right, we'll go ahead and pause the video and do the exploration, and then resume the video when you're finished. Well, I hope you had fun measuring the temperature of common objects around the house. Now that you've finished, please be sure to go to 1.20 and answer the questions. This concludes our Activity 10. Stay tuned for Challenge 9. I'll see you there.